ADITYA L1 is India's first mission to study the Sun and its various phenomena. It is a space-based observatory that will be launched by ISRO in the first week of September 2031. The mission aims to provide valuable insights into the solar corona, solar wind, magnetic field, and solar flares. The ADITYA L1 spacecraft will be placed in a halo orbit around the Lagrangian point 1, L1, of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. This orbit will allow the spacecraft to have a continuous view of the Sun without any interference from the Earth or the Moon. The spacecraft will carry 7 scientific payloads that will observe different aspects of the Sun from different angles. Some of the objectives of the ADITYA L1 mission are to study the dynamics of the solar upper atmosphere and its heating mechanisms, to study the initiation and propagation of coronal mass ejections and their effects on the interplanetary medium, to study the physics of the partially ionized plasma and the magnetic field in the solar corona, to study the in situ particle and plasma environment at the L1 point. The ADITYA L1 mission is expected to enhance our understanding of the Sun and its influence on our planet and space weather. It will also contribute to the global efforts of solar research and exploration. The scientific payloads of ADITYA L1 are 7 instruments that will observe different aspects of the Sun from different angles. They are Visible Emission Line Coronagraph, VELC. This payload will image the solar corona in visible and near-infrared wavelengths and measure the magnetic field in the corona. It will also perform spectroscopy of the corona in various emission lines. 2. Solar Ultraviolet Imaging Telescope, SUIT. This payload will image the solar photosphere and chromosphere in ultraviolet wavelengths. It will also measure the solar irradiance in these wavelengths and study the variations of the solar cycle. 3. Solar Low Energy X-ray Spectrometer, SOLEXes. This payload will measure the soft X-ray spectrum of the Sun as a star. It will also monitor the solar flares and other eruptive events in this energy range. High Energy L1 Orbiting X-ray Spectrometer, HEL1OS. This payload will measure the hard X-ray spectrum of the Sun as a star. It will also monitor the solar flares and other eruptive events in this energy range. ADITYA Solar Wind Particle Experiment, ASPEX. This payload will measure the solar wind particles, such as protons and heavier ions, and their directions. It will also study the variations of the solar wind with respect to the solar activity. Plasma Analyzer Package for ADITYA, PAPA. This payload will measure the density, temperature, and velocity of the electrons and ions in the solar wind. It will also study the interaction of the solar wind with the Earth's magnetosphere. Advanced Tri-Axial High-Resolution Digital Magnetometers. This payload will measure the magnetic field at the L1 point. It will also study the effects of the solar magnetic field on the Earth's magnetic field. The cost of the ADITYA L1 mission is 378 crore rupees, which is equivalent to about $51 million. This is much cheaper than most Hollywood movies, especially the ones that are related to space exploration. For example, some of the Hollywood movies that have a higher budget than the ADITYA L1 mission are Avatar, 2009. This movie had a production budget of $237 million and a marketing budget of $150 million, making it the most expensive movie ever made. The movie is set in the year 2154 and depicts the conflict between humans and the native inhabitants of a moon called Pandora. Gravity, 2013. This movie had a production budget of $100 million and a marketing budget of $80 million, making it one of the most expensive space movies ever made. The movie is set in the present day and depicts the survival of 2 astronauts who are stranded in orbit after their space shuttle is destroyed by debris. The Martian, 2015. This movie had a production budget of $108 million and a marketing budget of $94 million, making it another expensive space movie. The movie is set in the near future and depicts the survival of an astronaut who is left behind on Mars after a mission goes wrong. Interstellar, 2014. This movie had a production budget of $165 million and a marketing budget of $120 million, making it one of the most ambitious space movies ever made. The movie is set in the future and depicts the journey of a team of astronauts who travel through a wormhole to find a new home for humanity. As you can see, these movies have much higher costs than the ADITYA L1 mission, which is a real scientific endeavor that will provide valuable insights into the Sun and its influence on our planet and space weather. What is Lagrange point? A Lagrange point is a point in space where the gravitational forces of two or more bodies are balanced by the centrifugal force of their orbital motion. This means that an object placed at a Lagrange point will maintain its position relative to the other bodies without requiring any propulsion. There are 5 Lagrange points for any two-body system, such as the Sun-Earth system or the Earth-Moon system. They are labeled as L1, L2, L3, L4, and L5. The ADITYA L1 mission will use the L1 point of the Sun-Earth system, which is about 1.5 million kilometers from the Earth in the direction of the Sun. This point will allow the spacecraft to have a continuous view of the Sun without any interference from the Earth or the Moon. The spacecraft will also be in a stable orbit around the L1 point, which will reduce the fuel consumption and increase the mission lifetime. Thanks for watching this video. If you enjoyed watching this video, please like and subscribe to my channel.